science behind or the scientific thinking about why philosophically we might want to take the CPT, which I think that many of you could see what it was delivering and why it's been given a bit of a shake-up. So yeah, I'm going to sort of go up in a helicopter and look around the world and other industries, etc., in order to and sort of form this rationale. And so I'd like to start with kind of my view of different kinds of breeding schemes around the world. And so on this side here we have pigs and poultry, which effectively work like a pyramid. So for example, on poultry breeding there's 4 or 5 great big barns in Scotland with the very, very elite lines of chickens that supply about 50% of the broiler genetics for poultry production around the world. And those 3 or 4 barns, the genetic impact is multiplied up through these multiplier phases and has a massive impact. And this is sort of an example of genetic progress in chickens, and it's had a big impact. If you then go to dairy crops and aquaculture, they have completely different structures. And the reason is that these are it's the amount of semen or the amount of seed or the amount of eggs from an aquaculture system, the scale of production is massive, and that changes the sort of structures that those breeding programs have. And you tend therefore to get these sort of tightly defined targeted breeding programs that then have a very rapid and big impact through dissemination. Then if you take sheep, and beef is also like this, it's different. And this is nothing wrong. This is the way it has to be for sheep, but it is just different. And we see the shifting of genetic material around. And I've got the sort of the ute here with the crate on the back with the rams, and the shifting around, a little bit of semen, but often of swapping of lambs. It's kind of random, and shearing, and people sourcing good genetic merit from other places. So that's a different structure, and it's there just because you need the ram basically to be a heat detector and an AI technician for on a very, very large scale. So if we just jump back to the non-sheep industries again, this is sort of an overview I found on the internet of all the big breeding companies around the world, and they're focused on dairy, poultry and pigs. But a key aspect of the success and why these industries, big companies with thousands of people employed and huge impacts, and the aspect of what drives those businesses is that the elite animals make a massive genetic contribution. So this idea of genetic contribution as the top animals having a big impact is really the key message behind why we want to change the CPT. So I want to make a point with this slide is the importance of sourcing genetics from other places, of getting good genetics from other places, how important that is in genetic improvement in industries. So if you take the New Zealand dairy industry, you wouldn't know of anybody that knows what New Zealand dairy cows look like compared with other overseas country cows. They look completely different. They're smaller and much more an efficient sort of animal, just a different beast. But actually inside the genetics of our black and white cows in New Zealand is 50% overseas Holstein. So those genetics have had a big impact, but they've been refined to suit the New Zealand situation. So if you brought in a Holstein bull cold from the US, his daughters wouldn't perform very well here, but when they've been mixed into the New Zealand population and improved and adapted to our system, they've actually contributed a great deal. So also our beef industry, there's been actually a huge impact from genetics that's come in from Australia and the USA. I did a study of the Australian Angus genetic trend to work out where their genetic gain had come from, and something like 95% of it actually came from selection decisions that were made to bring better semen in from the US into Australia. So the point here is that finding genetics that's good from other places is a really, really powerful mechanism for shifting things on faster. So let's go back to the New Zealand sheep industry now. What's driving genetic gain here? So I don't know, 5 or 10 years ago, we did a study for SIL to look at, look through all the pedigrees and all the data, and what is it about the flocks that are making the biggest genetic trends? And we thought we might find, they have fast generation intervals, or they use lots of young rams, or they record lots of traits, and none of that explained the flocks with the high genetic trends. And it all came down to the choice of rams. In many, many different ways, the high genetic trend flocks were the ones that chose to use high breeding value size. So that was the secret to fast genetic trends. There was no other kind of magic recipe or thing you could do. So it wasn't about use of AI or faster generation turnover or what have you. So now the historic CPT was used for connectedness, so that you can compare across flocks, so to help with this finding genetic merit from other places. And it contributed hugely in that role. The challenge is that we've got a certain level of connectedness that is not really increasing that much. So what more can we do now? We kind of solved that problem with the CPT. How can we add value? So understanding the new traits was important, but it was always the old size, the size. People used the CPT as a marketing thing. I had a sire, our breeding group, or my stud had a sire in the CPT, and here's the booklet, and here how he ranked. Great marketing thing. But because of that, you put in old sires. Sires you're already confident that they were good because you didn't want to be embarrassed by them. So that's kind of fine, but those sires have already made their genetic contribution. So finding the information out from the CPT did not change the contribution that they had to the industry. So there's this question of the direction of genetic change now. So the progress in the New Zealand sheep industry and productivity, etc., and the genetic component of that is all about being prolificacy and growth rate. So there's some good stories around FE, but the majority of you have made genetic gains in index through prolificacy and growth rate. And the SIL indexes favour that, and those are the traits that are more heritable and more easy to record. But we need to think about more things, because we just can't keep on making sheep bigger forever, and we're getting to the limits of prolificacy where it's overshooting is a significant risk. So what about all these other things, costs, ease of management, twins, triplets, etc.? How can we leverage the CPT to get animals that are strong for these other traits making genetic contributions? So how do we change the direction then? So to me it's about young sires, the future, and finding these new young sires that are going to make a contribution across the industry. So the sort of features that we need to do that is we need a wide pool of sires. Just doing 30 or 40 sires in the existing or the historic CPT structure, it's not enough. We're not casting the net wide enough to find the best. So we need scale, and the budget's limited, so we need partnerships, etc. We also need multiple initiatives, because there are many sort of different types of sheep that suit different parts of New Zealand, different farming systems. We need lots of eggs in different baskets, so the more it can be spread out and adapt to different things, the better. So we've got to try and get the focus away from growth and NLB, because the future of sheep breeding is not going to be around those traits, it's going to be around other traits, new traits. And we need to have confidence in the results, because your businesses depend on the genetic trends you make and what you offer, and so there's got to be integrity, reasonable numbers of progeny, but that's got to be traded off against the scale, and we need good quality of recording. It can't be flaky. So, and finally, we need these new elite sires that we find to make a genetic contribution, because that has been the secret of success in these other industries that have made huge amounts of genetic progress. And so we've got to use these CPTs to find animals that make genetic contribution. I think that's my last slide.
Thanks, Peter.